This is the prerequisite review for section 3.4, Zeros of Polynomials. In this worksheet, we will only have one objective, and that will be to evaluate special products with complex numbers. So we are going to have special products with complex numbers. And once we perform the operations, we will write our answers in standard form. So let's go ahead and begin. We are looking for a little bit of a pattern. So if we have 7i multiplied by negative 7i, we'll take that negative, multiply 7 times 7, is 49, and I times I, which is I squared. Now we know that I squared is negative 1, which now makes this a positive 49. And leaving in standard form, we have 49 plus 0i. So we are looking for a pattern. Your guess here, what would your guess be? Yes, it is a positive 16. That's our guess. So let's go ahead and check that out. We'll take the negative, the 4 times the 4, and the I times the I. We have a negative 16 multiplied by a negative 1, and we have a positive 16, which is 16 plus 0i. Yes, and our guess was correct. So now let's see if we can use the pattern and just go straight away and write what this is. You guessed it, a positive 100. So we have 100 plus 0i. Very good. Okay, now we're going to look for a pattern in number 4, 5, and 6. So what do you notice? These are complex conjugates. And when you have complex conjugates, just the sign changes. So we have the real and the imaginary part are the same. These are the same. But then we have the change in sign. And as you can see, that is the same for both of these other problems. So taking a look at number 4, what we will do is we will go ahead and FOIL this. So first, outer, inner, and last. Now, when you multiply inner, take your negative, then multiply your numbers, and then multiply your I. So there should be a nice, smooth transition during multiplication. Now, yes, the outer and the inner are going to cancel, and we end up with 100 minus 16 times a negative 1, and we end up with 100 plus 16, and that's 116. And in standard form, it's 116 plus 0i. So what is the pattern? The pattern, if you can see here, this is our a squared, and this is our b squared. So if we have a minus bi multiplied by a plus bi, we will have a squared plus b squared. So let's guess here. So our guess, just from what we learned before, would be in number 4, the square root of 3 squared plus 4 squared. And that would be 19. Let's see if we're correct. So we have the first is the square root of 3 times the square root of 3. Outer is a minus 4i root 3. Inner is a positive 4i root 3. And last is a negative 16i squared. The outer and the inner cancel, and we have 3 minus 16 times a negative 1. And we have 3 plus 16, that's equal to 19. And that was our guess. So now what we're going to do in number 6 is we're actually going to use the pattern. So we are going to say that this is equal to the square root of 2 squared plus the square root of 3 squared. And that is 2 plus 3, which is equal to 5, or 5 plus 0i, which is standard form. So we can see some really nice patterns happening here and working out very, very well. Okay, let's look at number 7 and 8. As you can see, we have complex conjugates squared and then added together. So complex conjugates you can see, and then we are adding them together. So let's see what happens in this special product. Here we have 2 plus I multiplied by 2 plus I plus 2 minus I multiplied by 2 minus I. Foiling this, we would have first, outer, inner, last, and again first, outer, inner, last. So as you can see, we have our outer and inner of both canceling, and we end up with 4 plus I squared plus 4 plus I squared. So we have 8 plus negative 1. Actually, let me wait on that 8. We have a 4 minus 1 plus 4 minus 1. So we end up with 6, which is equal to 6 plus 0i. Now this pattern may be a little bit harder to see, but basically what we have is our, our 2 squared and our 2 squared. And then we will subtract 1 and subtract 1 for our L of our FOIL, and outer and inner cancel. So looking at that pattern, you could say that this was 2 squared minus 1 times 2. So that's 2 times 3, and that's equal to 6. So this is our pattern. I think I would go ahead and just multiply this out, but let's see if we can come up with this here. So here we would have 2, let's write using the pattern. And here we would have 2 times 4 squared. And here we would have minus, and then we would have 3 squared. So here we would have 2 times 16 minus 9. And we have 2 times 7. That's equal to 14, which is 14 plus 0i. Now, you might be wondering about this pattern right here. And that 1 was because it was 1i squared. So we could also write this pattern that if we have a plus bi squared plus a minus bi squared, which is what we have, complex conjugates squared added together, we are going to get twice a squared minus b squared. And we could go ahead and note that here in number 8, what we have is a is 4 and b is 3. So here, that product in number 8 would be equal to 2 times 4 squared minus 3 squared. So maybe not a pattern you would want to memorize, but one that you could actually see exists. And that concludes this worksheet.